Audio Jungle. Audio Jungle.
Hello everyone, myself Naren Singh Maurya and hope you all are doing well. Guys, today we'll solve a GATE 2016 problems, performance problems, okay? And here in this GATE 2016, if you check, this is question number 25, okay? So the question will read, the load factor of an aircraft turning at a constant altitude is 2. The coefficient of lift required for the flight, turning flight, as compared to level flight. The lift coefficient required for the turning flight as compared to level flight at the same speed will be. Okay. This is the MCQ. Option A same, option B half, option C double, option D 4 times. So we'll solve this. Here it is given, data first will write N during the turning load factor L by W. Okay, L by W, it is nothing but 2. Okay, when it is turning flight. Only in turning flight, okay, load factor will be greater than 1. Anyway, so two condition it is given. First is turning flight condition, they have given a load factor and they are saying uh, they are comparing that load factor during turning and level flight. So anyway, first we'll draw here level flight and we'll write that value. So this is the level flight, check, this is the level flight here. The level flight means no turning, steady level flight. So W, and this is what, L. So this is the steady level flight, or you just say level flight. All right, and level flight, and this is the another diagram. Okay, here it is. All right, so weight is what, as usual, it will be in vertical downward, and now this is nothing but lift force. Okay, and from the horizontal, this angle will be called as banked angle phi. Okay, this angle will be phi. Okay, or better to say, otherwise this angle will be turning, but now I will give the bank angle with respect to the uh, horizontal wing, or with respect to wing I will give the direction, so it will be better for the calculation. Okay, now check, because steady level you had taken, this was the reference, so here why it is steady level, why it is not turning, because your wing is what, in horizontal direction, but it is here in turning that wing is what, tilted from the horizontal angle. So I will mention this is the angle, bank angle phi. I hope it is clear, this is called bank angle. Okay, So whatever the angle here, the same angle you may get from the vertical also, no doubt. Same angle you may get, right? So this is lift. So what this component? This will be L cos phi. All right. Now this is the L cos phi. So this horizontal will be L sin phi. It is turning, so it will follow the circular motion. Okay. So that force you may get here away from the center, yes or no? Centrifugal force. So if you check the force balance for this, what is the force balance? L sin phi is equal to mv square by r 1, and second L cos phi is equal to w equation 2. Hope you understood. It is very basic there. Okay, very basic. Now, so for the steady level, you can write here steady level flight. You can write load factor N1. And for the steady level flight, what is the load factor? First of all, what is the load factor? Is the lift force divided by weight of airplane or aircraft. So in steady level condition, L by W is the load factor. And at turning, because they are asking comparison of load factor during steady level flight and turning flight. So at turning flight, load factor you can write N2. N2 is nothing but again lift force divided by weight of airplane. Yes or no? So you check, this is called N2. So lift force here, it is nothing but L by W, because if you calculate uh, lift force, so lift is equal to W by cos phi. I can write this. So it will be W by cos phi divided by W. So cancel out 1 upon cos phi. Yes or no? Now, and that load factor it is given 2. During the turning flight, it is given 2. So basically here they are asking the coefficient of lift. Coefficient of lift they are asking. Load factor during turning they have given. Yeah, during the turning load factor they have given. So anyway, so you can calculate this. So during the turning, what is the load factor? 2. N2 is nothing but 2 they have given, and N1 is the L by W. So what is the lift coefficient? So lift is equal to what? Lift is equal to weight, and this is nothing but half rho V square S into CL. In which case, if it is steady level, if it is steady level, then L is equal to W. So what is the CL? CL will be 2 L divided by rho V square S, or 2 W divided by rho V square S. That is the equation 1. All right. Now at turning flight, what will be the CL at turning flight, what will be the CL? So that CL, if you write, it is nothing but 2L divided by rho S V square, okay, is equal to, if you write L in terms of weight, so check what is the L in terms of weight. L is equal to, L is equal to 2 times of the weight, yes or no? Because if you check L by W, that is the load factor is given 2, so L is by W is equal to 2 is given. So what is L? L is nothing but 2W at turning condition. So L is equal to 2W. Okay, check 2 into this 2W is what? 2W by rho S V square. This is during the steady level. Check CL at steady level. So CL at, I will write turning flight TF. So this value is what? CL at steady level flight. So CL turning flight is equal to 2 times of CL at steady level flight. I have taken so much time here. So what is your answer? Check. Double. Option C is correct. Okay. Answer is, means during turning CL will be 2 times. So here in this problem, comparison was not between load factor, that comparison, but between lift coefficient. So even though if it is like sometimes they may ask that comparison between the load factor, okay, as per given data you have to relate, so that load factor you have to relate by this way. You have to write load factor for the steady level flight separately, and turning flight you have to write separately, and then you can compare. Okay, remember, during turning flight, load factor will always be greater than 1. How you would know? Because that is also asked one time. How you would know? Because this is the load factor, check, and this load factor you got N2, which is during the turning, 1 upon cos phi, and 1 upon cos phi is nothing but sec phi. And sec phi value is always greater than 1. Hence, load factor will be greater than 1, because what is the range of cos phi? It is 0 to 1. Cos phi range is what? 0 to 1. Cos 0 is uh, 1, and cos 90 is 0. So that range, if you check, it is nothing but 0 to 1 in radian, I'm saying. Okay, so definitely 0 is not possible for load factor. It will go for infinite if you write um, cos 90. So uh, it will be 1 upon cos 90 means 1 upon 0, that will be infinite, so that is not possible. And obviously turning at 90 degrees is not possible at all, yes or no? So a banked angle, 90 is not possible. So so like value of the cos phi, that range is 0 to 1. So sec phi, if you check, 1 upon cos phi is sec phi. So whatever the value less than 1, 1 upon less than 1, like 1 upon 0.5, so it will be greater than 1 automatically. So load factor, this was asked in gate, that's the reason I'm discussing. Okay, so during turning flight, always remember load factor will be greater than 1. Always remember. Okay. See, even in this problem also, that load factor it is given 2. But in climbing flight, in gliding flight, okay. So climbing, gliding, or steady level, it is less than 1 or equal to 1. Less than 1 or equal to 1. But during turning flight, always greater than 1. This was asked in gate problem. So that's the reason I have discussed here. Anyway, this problem is done. Now this is problem number question number 50. Okay, question number 50, and here this is the again gate 2016. Okay, so 2 marks problem. So aircraft weighing 10,000 Newton. Okay, so given data I have to write here first. 10,000 Newton is flying at flying level at 100 meter per second. So first I will write weight of the aircraft. It is nothing but 10,000 Newton, flying level at 100 meter per second, and it is powered by a jet engine. The thrust, okay, the thrust of the engine is given 100 meter per second, and it is powered by a jet engine. The thrust required for the flight is 1000 Newton. So thrust required, I will write this for jet engine. How much it is? 1000 Newton. The maximum possible thrust produced by the jet engine. So thrust produced by the jet engine means thrust available. Okay, thrust available means I will write TA means thrust available. How much? 5000 Newton. Okay, the minimum time required to climb. Minimum time required climb 1000-meter altitudes. We need to calculate. So I will write thrust minimum time required. So T min R, minimum time required, we need to calculate when flight speed is 100 meter per second. When flight speed is 100 meter per second. Okay. So this is the climbing problem basically, and it is asked for 2 marks. So we have to calculate the minimum time required. So for this is the climbing problem. So I'll draw the diagram first. So this is the climbing problem. Okay. Anyway, the climbing angle is what? Gamma. Again, this is the velocity. Okay, and obviously this will be the drag. Perpendicular to this velocity will have a lift. Perpendicular downward will have a weight. Will resolve this. This is the gamma, because this is the gamma, so this component will be cos component, and one component will come this side, W sin gamma. So we'll write the equation for this. Okay, for the climbing flight. Climbing flight, where gamma is the climbing angle. So the same diagram you can draw. Check. This is gamma. This velocity, because this is the V, or you just say V infinity, it's your choice, V infinity, and because it is climbing in this direction, so it will, climbing meaning itself is it will gain the altitude. Climbing means it is gaining the altitude, so altitude will be increasing. Okay, so that in vertical direction also it will have a velocity component Vc, and in horizontal direction it will have a Vh. So this will be used to calculate range, and this will be used to calculate altitude, like how much altitude it is gained, h. I hope you understood. Yes or no? It's a very simple problem, but yes, concept you have to apply. So this is the C. Okay, I will correct this. It looks like a E, but it's a C. Okay, V C. So what is V? It is climbing speed, or it is also called as, or it is also called as rate of climb. Okay, check what is the VH. It will be V infinity cos gamma, and here check what is the VC component, sin gamma. Yes or no? So VC is equal to V infinity sin gamma, and it is also called rate of climb. You need to remember this. Okay, this is very important result I am telling you. Hope you understood. All right. Now we need to calculate the uh, what is the speed, what is the time required to climb from one level to another level. Okay. So from the diagram here, anyway. So again I will draw this diagram. I told this is used to calculate range, and this is used to calculate altitude. Okay. So if here this altitude is what h1 and here it is h2, so what is this altitude dh? What is this velocity component? It is nothing but vc, and this is nothing but v infinity. So what is the time? Time required to climb from h1 to h2. Hmm? Huh? So check vertical velocity component is given, distance is dh is distance which is given. So what is the time? What is the time? It is distance by velocity. Hmm? Simple, I am telling you, very simple way. Distance divided by time required. Distance divided by velocity. Velocity. Simple formula I am using here. What is the dh? Dh velocity distance is dh. What is the velocity vc? Why I am writing dh? Because it is climbing from h1 to h2. If it is climbing from sea level, no problem. 0 to h. Now if you want to calculate time required to climb from h1 to h2, so you just integrate from h1 to h2. Your problem is solved now. Yes or no? Your problem is solved now. So let me divide this page. All right. So what is the first VC? If you know the VC, then you can calculate, because DH it is given 1000. It is given 1000. See that altitude. It is mentioned. Minimum time required to climb 1000. So it is not said like from 500 meter to 1000 meter. It is not mentioned. Directly it is given 1000 meter. So DH means total distance is given. Like H2 minus H1 is given 1000. So that we can handle, no problem. Very important. Here you need to calculate first VC. What is the VC? V infinity sine gamma. If you write the equation for this, so what equation you may get? Check. You will get d plus w sine gamma is equal to forward. Forward motion will be thrust here. Will be thrust. So what will be the uh, w sine gamma? T minus d. What will be sine gamma? T minus d by w. Yes or no? So check what is VC. Vc is v infinity sine gamma. What is sine gamma? It is t minus d divided by w. You can relate. What is the sine gamma? Check. Sine gamma is t minus d by w. So directly I can write here Vc, which is nothing but rate of climb, and that is nothing but t minus d by w into velocity. So check data. What data they have given? Thrust required at for level flight. What is the thrust required? So level flight. What is the concept of level flight? Basic concept you have to use. That's all. At level flight, thrust is drag and lift is weight at level flight. So whatever the thrust it is given, thrust required, it is nothing but drag. Thrust available, it is given, weight is given, you can keep all the value. What is thrust available? 5,000. What is the thrust required? Means drag, that is 1,000. What is the weight? 10,000. You'll keep all the value. What is the velocity? That velocity is 100 meters per second. 100 meter per second. Yes or no? You write all the value here. So 100 thrust available, it is nothing but 5,000. Yes or no? Thrust required, what was the thrust required? It was given, check. It was given 1,000. What is the weight? 10,000. We'll calculate Vc. How much? We'll write 5,000 minus 1,000, okay, into 100 divided by 10,000. How much it is? 40. Check that rate of climb is nothing but we are getting 40. Yes or no? This is the rate of climb. Now if you want to calculate time, so what will be the time? Okay, ds divided by vc, h1 to h2 means h2 minus h1 divided by vc. So time t is equal to h2 minus h1 is given 1000 meter divided by vc is given 40 meter. So what will be time? Wait, 1000 divided by 25. So for the jet engine, 25 seconds only required minimum time to reach 1000-meter altitude. That's the solution for this problem. So here I have gone very slow so that each and every steps you can understand. But in examination directly you have to write the uh, formula and equation you make, like what is the climbing formula? Resolve the force, calculate ROC immediately, distance by ROC khatam. ROC means rate of climb over. Okay, this is the solution for the problem. Again, any like at any step, suppose you are not getting the you have doubt or something, then immediately you write message, okay, on comment box, so I will reply. Okay, now we'll go for the next problem. I hope you all understand this solution. This is the next problem. Check here. A glider, okay, weighing 3,300 Newton is flying, okay, is flying 1,000 meter above sea level. The wing area is given and air density is given under zero condition. Velocity for maximum range is they are asking. What is the velocity at maximum range they are asking? Okay, so check, and related data table is given. Okay, so from the table we'll check what is the requirement, accordingly we'll find the data from the table. First of all, one glider we have, so obviously glider will always glide, huh? No climbing in glider, it is gliding. Gliding means that from very high altitude, uh, It will be like uh, see, unpowered vehicle means there will not be engine, but doesn't mean gliding condition there will not be engine. Maybe engine is there, but it is turned off. Okay, switched off that engine or turn off that engine. So that will also called a gliding flight, unpowered flight, and very frequently known like glider is what frequently you may have seen like. From the hill and all that glider you can hold and you can jump from the like very high altitude like hill and also it will glide and you will reach to from hill to ground. So that is a very well known right glider. But for the unpowered aircraft also called gliders. So glider another word is what unpowered aircraft. All right, means aircraft is there, it was flying with the engine, but some at some condition that engine is what turned off, so that will also called a now unpowered aircraft, or now it will be called as a gliding condition. Okay, all right. So this table is given, we'll follow this. So now check. So this is the glider, I will draw the diagram. So from somewhere, no, diagram is not. Okay, that for the glider gliding angle you say gamma. Okay, and it is coming downward direction, so obviously weight will be acting downward. Okay, and lift will be perpendicular to the velocity because this is the velocity here. So lift, and here thrust component will come, but it is gliding condition, so thrust will be 0 and opposition force will be drag. Okay, this is gamma, hence this component will here this is also gamma and this component will be w cos gamma, and here we'll have a w sin gamma. If you resolve that force, what you may get, drag is equal to w sin gamma and L lift is equal to w cos gamma. Or from this equation 1 and 2, if you resolve you may get this from equation 1 and 2, tan gamma is equal to sin by cos. So it will be d by L, drag by lift force. Hope you understand. Yes or no? What they are asking in this problem, they are asking range. So I will show you the triangle for this. This will be the altitude and this will be the range, just like a climbing flight I told here. What is the angle? Gamma. This velocity component is nothing but, in terms of velocity this will be the v infinity, and this will be the, in terms of velocity I am telling you, vd called descent velocity, and this will be the horizontal velocity. Huh? But velocity, in terms of velocity it is not required, we required range and altitude. Okay, so because it is mentioned that 1000 meter from sea level, so h is given. Okay, now so we'll write this formula so we can relate range and this altitude. So tan gamma is equal to what? H divided by r. Yes or no? R is nothing but range, H is nothing but altitude. What is the gamma? Gamma is nothing but gliding angle. Okay, anyway, so your job is to calculate range, which is nothing but H tan gamma. So you have this tan gamma, equation number 3, equation number 4. Now we can write from equation 3 and 4. What is the range? H upon tan gamma you got. So H divided by what is the tan gamma? Tan gamma is D by L. Okay, or H L by D, or H L by D also you can write CL by CD, because what is L by D? L is nothing but half rho v square S CL, and what is drag? Half rho v square S CD. So rest value will be cancelled out. You will have CL by CD. So check. They are asking what is the velocity for maximum range. What is the velocity for maximum range? You need to calculate. First check what is the maximum range condition, and for that maximum range condition you have to calculate velocity. All right. Now, so here R max will be what? H into CL by CD max. Yes or no? Check CL by CD max from the table. What is the CL by CD max in the table? Check this data. 25 is the maximum, 25.4, 25. This is the maximum CL by CD. Yes or no? This is the maximum CL by CD. All right. Now everything is given, like area is given, density is given. So how to calculate velocity? You write it. So check what is the uh, lift weight is given. Weight is given. Done. In fact, gliding angle is given. Gliding angle in degree is given. So check. Write the velocity. So what is the lift force? It is half rho v square S into CL. What is V? 2L rho S into CL. All right. 2 into in gliding, what is the lift force? Check. Lift force is W cos gamma. Yes or no? Lift force is what? W cos gamma divided by rho S area into CL. But this velocity is what? This velocity you are calculating at R max. Okay. What is the condition for R max? CL by CD max. Hmm? So what is the value for the velocity? You need, for velocity you need CL. So CL you need to calculate where CL by CD is max. So what will be the value of CL at CL by CD max? Check. CL by CD is to 25.7. Check that CL value. So this value will be used directly. That's the reason table is given, so that it will be very easy now. For maximum CL by CD, you will have a maximum range condition, and at maximum range condition you have to calculate velocity. So in velocity, if you check the formula, what is the velocity? That velocity is nothing but 2L divided by rho S CL. This is the formula. So at maximum range, what is the velocity? This is the velocity formula, and in velocity CL value you are getting. So this CL will be related to maximum CL by CD, because maximum CL by CD you are getting maximum range. So 0.9. Hope you understood why we are using 0.9, and what will be the angle? 3. Okay, that gliding angle. So you can write 2W. What is the weight? Check. Weight is 3,300. 3,300. Cos gliding angle is 3 degree divide by density. How much density is given? It is I think 1.23, no? 1.23, and area is 14.1. 1.23 into area is 14.1, and CL you have seen it is I think zero point 0.9, right? Zero point 0.9. Check this value. Hope you understood how to use this table. 0.9. We'll calculate this. So 2 into 3, 3,300 cos 3 divide by 1.23 divide by 114.1 divide by zero point 0.9. So you will get root 422.2616. Okay, you take the root of it, you will get 20.5. Check up to what decimal points they had asked. They had not asked anything, but yes, up to 2 decimal you can write, huh? Meter. This will be your 20.5. I hope you understood, and you hope you understood this table also, how to use this table. That's all. So these are the problems was asked in GATE 2016. All the problems we have solved here. Any doubts for any problems at for any steps if you are getting, then you can write message, okay, in comment box, so I will reply. And keep revising the topics, do hard work. All the best. Thank you.